Hello students, welcome back to the class. As you know, we are doing the chemical kinetics chapter. This is the second session you are joining with. So now let us start the class with the topic units of rate of reaction. As you can see on the screen, I have written two units here. One goes for solid and liquid and the other goes for the gaseous atoms. Okay, so as you know that the formula for rate of reaction is concentration divided by time. So this ultimately means we are talking about some liquid or some solid, right? So for solid and liquid you will get mole per liter per second. This is the concentration divided by time, that is second, and second will go in the numerator, which will become second inverse. Clear? So you will get mole per liter per second. Next, for gaseous atoms, they don't really show the rate of reaction in terms of concentration but in terms of pressure, because gas exerts pressure. So likewise we can calculate the rate of the reaction in terms of pressure of the gas. So here you will get atm per second, that is atmospheric pressure divided by time, that is your atmospheric per second. Next, as you know that a chemical reaction, when a chemical reaction is in progress, the rate always changes. Why it changes? That's the question. Because the concentration of the reactants or the concentration of the products never remain the same. Okay, so when we talk about a reaction, suppose A plus B is providing to give C, okay, providing the product C, then you know that in course of time A and B will decrease while C will increase. It means what? At every point of time there are different concentrations of A, B and C, and hence the rate will also change. As time is increasing, the reactants are getting over, the reactants are decreasing, hence the rate of the reaction will also decrease, and ultimately it will stop, it will come to zero, because the aim that the product formation is over now. So when you start, it is like having the maximum rate, and when you end, when the reaction is over, it is completed, then you will get at zero. So now you know that at different time intervals the rate of a reaction also changes. And why it changes? Because the concentration of the reactants does not remain same, it always decreases. Is it clear? So now how to calculate the rate of a reaction? Here you cannot say we will take an average rate, because when we take average, when there are variables, suppose you are doing a reading, in the first reading you have got 2, in the second reading you have got 2.1, in the third reading again you have got 2, in the fourth reading you have got 2.2. so you are talking here about a variable, about a number which changes, it's varying with time. So here you can take the average. Clear? But for rate of a reaction you cannot take average, because for every interval you will get different values. It will never happen that you are getting the same value again. You cannot take the average. We take average when we don't know the exact value. Okay, when we don't know the exact value. But for a rate of a reaction we do know the exact value. At suppose initial stage, suppose when the time was 6 a.m. we have started the reaction at 6 a.m. suppose, you know what is the rate of the reaction by calculating, and at 6 point, suppose after 6:05 you know what's the reaction, and at 6:07 you know what's the reaction. So this rate and this rate will never be same. You will never get this rate in how much time you calculate. You will never get the repeated rate. Is it clear now? Means what? At a particular interval of time or at particular time you will get a constant value and a fixed value, that is fixed. So there is no point of taking out the average. Here you have to do one thing, you can take the instantaneous rate. Suppose you want to calculate the rate of a reaction at a particular point, suppose 6:05, then at that particular point you can calculate it. Okay, so here I have written these values just to show you that in the course of time the value of the rate of a reaction always decreases. Okay, so initially it was 12, then next 11.8, like that. Now when we talk about the instantaneous rate, R instantaneous is given by D, that is your differential. You know already, I think so, you have learned in mathematics, so I'm not going to go in details about it. Just that the differential of R divided by dt. Okay, in terms of dt you have to measure. Now what is dt here in chemistry? Okay, we are not means going fully mathematics, but we have to understand the terms. So dt means dt. When we talk about delta t, we mean to say the change or the difference, right? But when we say dt here in chemistry, we mean very small change in the time. Suppose you have started a chemical reaction 5 minutes ago, then you just want to calculate the rate of a reaction after 30 seconds or after 10 seconds. That will be the instantaneous time, instantaneous rate, and the time interval is in seconds. Clear? So 1 second, 2 second, 3 second, like that also you can calculate the rate. Clear? So there is a very small change in the time, that is why you will use the dt here. Is it clear? I hope this is clear. Okay, and this you already know why I have written here dr and why I have written here dp. Clear? No, because this is the product, and product is always increasing, therefore it is a positive value. Next, the reactant is always decreasing, therefore this is a negative value. And why these are equal, why this term is equal to this? Because the number of moles of R that is decreasing will ultimately predict the number of moles of product formed. If 5 mole is decreasing here, means 5 moles of the product is formed. So this is very clear to you all, I think so. Next, let us go to the factors influencing rate. Okay, what are the factors that is influencing rate? Because you know that the rate does not remain the same in the whole course of the reaction, it always varies. So what are the things that affect the changes in the rate, whether it is increasing or sometimes it might decrease? Here I have said that the rate will always decrease in the course of time. Why? Because you are not doing anything, you are not putting any extra effort, you are letting the reaction to happen by itself when you have started it. Now, there can be a situation where you can increase the rate of the reaction. Let us think it here once more. When I'm saying that the rate is decreasing, I mean to say that the reactants are decreasing, that is why rate is decreasing. But you can do one thing, no, that you can add more reactants here by yourself in between the reaction. You can add more reactants here. Suppose you can see that A and B is decreasing, the reactants are decreasing. You can add some reactants over, right? So at that time what will happen? The rate will increase. So means there is a direct relation between the rate and the concentration. You can increase it or you can decrease it, but if you leave it to itself, then it will always decrease. So first of all, concentration, and with it we will get the rate law, rate equation, rate expression. So let us see what does it mean. When we try to relate the rate in terms of concentration, we will get the rate law. Okay, so let us consider equation or a chemical reaction where we will use the stoichiometric A. For A means A number of moles is there. Okay, here for B molecule, B number of moles is there. For C now number of moles is there. Okay, so like that the reaction goes on. This is a generalized equation. When we talk about the rate, it is directly proportional to the concentration of A to the power X, concentration of B to the power Y. Now one more important thing, X and Y can be equal to A and B respectively, but not always same. So X and Y may or may not be equal to the stoichiometric coefficients. This thing you have to remember. By accidentally sometimes it becomes equal, while most of the time it is not equal. So it is not dependent on the stoichiometric coefficients. So by seeing this reaction, you can never make the rate law. So rate law, you have to do the experiment. By seeing the reaction, you cannot determine the rate law or the rate constant that you are going to get now. So this proportionality sign will be removed by using a constant term, that is K, which is known as the rate constant. And as you know, you can put one more thing here. In place of rate, you can put differential of R in terms of dt. Clear? So here this is the same thing, and this equation, rate equal to K concentration of A to the power X concentration of B to the power Y, is known as the differential rate equation. Now let us see the proper statement for the rate law. It is the expression in which reaction rate is given in terms of molar concentration of reactants, with each term raised to some power which may or may not be same as the stoichiometric coefficient of this reacting species in a balanced chemical equation. So the rate law is the expression which is given in terms of molar concentration of the reactants. In terms of reactants, not in terms of product. Okay, so in terms of reactant you have to get, and which the concentrations are raised to the power some powers which may or may not be equal to A and B respectively. Clear? So this is the rate law statement. Now you know what is you have to know what is X and Y. So this is basically the order of a reaction, and this order, since you cannot determined by seeing the reaction, X and Y cannot be determined by seeing the reaction. It has to be calculated experimentally. You have to do the experiment in order to calculate X and Y. Since you don't know X and Y by seeing the reaction, how can you know the rate law by seeing the reaction? Is it clear? So this is the thing here. What is the order? X plus Y equal to order. The order of a reaction is given by the concentration raised to the following powers. So X and Y, X plus Y will give us the order of a reaction, whether it is 0 order, first order, third order, and so on. So 0, 1, 2, 3, all these are what? Integers. So it can be 0, 1, 2, 3 whole numbers, or it can be a fraction. I hope this is clear. Now you see what is order? Sum of the powers of the concentration of the reactants. Sum of the powers of the concentration of the reactants is called the order of a reaction, and it is found in the rate law expression. In between, we have to talk about elementary and complex reaction. Okay, by seeing any reaction, you cannot always judge what is going on in the reaction. Okay, here you see we have taken a reaction AA and BB, CC and DT. Okay, so like that we have taken. By seeing this particular reaction, you cannot always determine what is going on actually in the reaction. This is just an idea that A and B may react to give C and D. This is just theoretical. You don't know whether really A will react with B or not. Clear? You have to do the experiment. Okay, you have to do the experiment, then only you will know, yeah, really C and D is forming from A and B. Clear? So you have to do the experiment. By seeing a chemical reaction, you will never know that whether it is really occurring or not. So this is basically an idea. And how actually these are formed means how the experiments are done based on the theoretical. Why, in order to do any experiment, you know, you have to have a theory base. The base is theory. You have to have an idea first. You have to imagine something, then only you can do the experiment. Similarly, chemical reactions are actually a sort of imaginations, and which is done in experimented in the lab. Okay, only then an reaction is established. Only then you can say that, yeah, really A and B is reacting to give C and D. So this is the thing here. Now while seeing the reaction, it is very clear that A and B gives C and D, but you don't know what is happening in the reaction, whether A and B is directly giving C and D, or first of all it is converted to something else, and that product is converted to C and D ultimately. So you don't know. In such cases, there are two types of reactions, that is your elementary and complex. Elementary reactions are those reactions which takes place in one step. In one step it gets over, while the complex reactions are those reactions which do not occur in one step, but they undergo a sequence of steps. There are so many steps in between, and you know that in between those intermediate products are occurring. Okay, so there are two types of reactions here, elementary and complex, and this idea you have to use it later on in the chapter. Now let us go to the units of order. Okay, so the rate law is given by rate equal to K, then concentration of A to the power X, concentration of B to the power Y. Or you can write K equal to rate divided by these two terms, right? So this is written here, you can see. Now in order to calculate the unit of rate, you have to know the unit of rate constant. You have to know the unit of rate and the unit of these two concentrations. So for rate, it's concentration divided by time, and this is concentration, right? So concentration x plus y, and how it became x plus y, how we can add the exponentials when concentration of A equal to concentration of B. Means what? If suppose m to the power A is there and n to the power B is there, I'm saying I can write m to the power A plus B when it is possible, when both these are m, right? When both these are m, then only I can write this. So we have written that m is equal to n. Okay, so the value of m is equal to value of n. Then only you can add the powers. When your base is same, then only you can add the powers. So when our bases are same, means when the value of the concentration of A present in the reaction is equal to the value of the concentration of B, then only we can use this formula. Okay, so let us consider that these are equal. Now concentration by time, we have written here concentration by time into this is left, so 1 by concentration to the power n. So just for simplicity, we will consider the order as n. Okay, so this is the order, x plus y is the order, and in short we can write small n. Now what will be the unit of the rate constant for different orders of the reactions? We can calculate it. Okay, we can calculate it in a simple way here. Let us consider zero order, means order is 0. Order is 0 means what? X plus y is 0 means what? N equal to 0. Okay, so we can put the 0 here. What we will get? Concentration by time means mole per liter by second into 1 by mole per liter to the power 0. Clear? So whatever base, okay, anything to the power 0 is equal to 1. X to the power 0 is equal to 1. Any number that is equal to the power any number to the power 0 is equal to 1. So this will become 1, and what is left? Mole per liter per second. Got it? Now for the second order, first order, what you will do, you have to put 1 here. Okay, the value of 1 or x plus y equal to 1, so 1 you can put here. Now this is mole per liter, this is mole per liter, you can cancel it. What is left? Only this is left, so s to the power minus 1, s inverse. Next, second order, just put a 2 here. Go with the formula. If you are confused, you see the formula is here. When we say second order, you have to put the 2 here. When we say first order, put 1 here. And concentration, you know, it's mole per liter, time is second, simple. So when we say second order, you have to put a 2 here. So 1 mole per liter is here and 2 mole per liter is here. So this will get cancelled, and here only 1 will be left. So what will go? Mole per mole you will get, no? So all this will go up in the numerator. So per mole, liter to the power minus 1 will become liter, because it is again inverse, no? Liter to the power minus 1. Okay, if we take this one up, what you will get? Minus 1 to the power minus 1, no? So liter. Clear? Simple. Then s will go up, it will become second. Is it clear? So by seeing the units, by looking at the units of the order, you know that what order is it. Okay, by looking units of the rate constant, by looking at the units of k, you know what order it is. Clear? So this thing you have to memorize, or you can calculate like this. So this much for today. Next we will do the molecularity and the other topics related in this chapter. Thank you.